Welcome to Study Loop.
So the probability of winning is 1 out of 6, since there is a winning cap on one of every sixth bottle. If you think about what your probability distribution would look like, we might win on the first purchase, the second bottle we purchase, the third, the fourth, the fifth, the sixth, the seventh, and so on. This distribution does not end, but what we do know is that if we take the probabilities of each of the outcomes and we add them all together, they will equal 1. And since we stop counting success once we have our first success, then we are dealing with a geometric probability. And with geometric probabilities, we have a formula that reads the probability of an event occurring is equal to the probability of success multiplied by 1 minus the probability of success raised to the x minus 1 power. So in part A, we're asked to determine what's the probability of winning on the first purchase. So in this case, x is 1. So we'll utilize the formula. We'll place a 1/6 in place of the 1 or the p. We're going to multiply by 1 minus 1/6 raised to the 1 minus 1 power. And you would pick up your calculator and you would get an answer of approximately 0.1667. For part B, we're asked to determine the probability of winning on the third attempt. So that's going to be an x value of 3. So we're going to substitute into our formula 1/6 times the quantity of 1 minus 1/6 raised to the 3 minus 1 power. And that gets us an answer of approximately 0.1157. Now for part C, in part C, it's slightly different because this isn't asking us for when the success occurs. It's saying what's the probability that you don't win on the first 5 purchases. So that's really saying that you do win on the 6th purchase or the 7th or the 8th or the 9th or the 10th, and it never ends. So we can't use this formula an unlimited number of times. So what we need to do is, instead of focusing on the 6th, the 7th, and the 8th, we're going to instead focus on filling in the top part of this chart. Now, we already know the probability of winning on the first bottle is 0.1667. We also already know that the probability of winning on the third bottle is 0.1157. So we're going to take some time right now to fill in the probability of winning on the second, the fourth, and the fifth. So the probability of winning on the second purchase would be 1/6 times the quantity of 1 minus 1/6 raised to the 2 minus 1 power, which is approximately 0.1389. And we can fill that in. And the probability of winning on the fourth would be 1/6 times the quantity of 1 minus 1/6 to the 4 minus 1 power, which is about 0.0965. And the probability of winning on the fifth purchase is 1/6 times the quantity, 1 minus 1/6, raised to the 5 minus 1 power, which is approximately 0.0804. So when it comes time for us to calculate the probability of winning on the 6th or the 7th or the 8th or the 9th, what we'll do is we'll take the fact that the entire chart adds up to 1, and we'll take away the sum of the probabilities from 1 through 5. So if we add up the probabilities of 1 through 5, we get a value of 0.5982. And therefore, the probability of winning on anything but the first 5 ends up being approximately 0.4018.